So in this video, I'm going to show you how you can use R and ggplot and dplyr to recreate one of the most famous plots that has come into the world in recent times, which I think is quite a nice illustration of how you can get to a kind of unique product just through thinking about how to use the ggplot2 and dplyr functions in particular ways to create something that perhaps isn't just your standard kind of output of a simple table or a simple plot. It actually can be quite easy to get to something really innovative and exciting. So we're going to talk about this warming stripes plot, which I'm assuming most people watching this will have come across before, especially for me living in Reading. It's kind of hard to escape. It's one of our biggest cultural exports from recent years. As you can see, it gets plastered on festival logos and masks and the covers of newspapers or vases, pretty much anything. Which is just a really unique and innovative design for showing this trend of temperatures over time. So if you're not familiar with the plot, the different shades of the bars, these represent the difference between annual temperatures and a reference temperature. So each stripe represents the temperature in a different year. So what we're going to need to think about if we want to recreate this particular plot using R is, okay, what is the process we need to work through to get to this particular outcome? So there's kind of four main steps where we first of all need to get some yearly average temperatures. Then we need to calculate a reference temperature. So in the methodology which is used in the kind of classic warming stripes from Professor Ed Hawkins from the University of Reading, he uses the average temperature between 1971 and 2000. And then for every year, we want to calculate what we call the anomaly, so the difference between the yearly average and the average over the reference period. And then finally, we want to make the plot where we've got our different stripes and we're going to map different colors onto different values for our anomaly. There's actually kind of a step 0 as well, which is I need to get some data. And quite conveniently, living in the UK, our Met Office releases a lot of climate data going back 150 years, almost 200 years in some cases, for a number of different stations. So I just went onto their website the other day and downloaded right up to just a couple of weeks ago all of the data they had available for Oxford. I've kind of done a little bit of a cheat here as well because I'm using a slightly tidied version of the data as I go into my first step in R. If you want to see how I did this tidying process, I'm going to put that in a different video because it's a little bit fiddly and complex compared to the process of getting to the plot, which is just using a lot of dplyr and ggplot2 commands that you've perhaps seen already. Okay, so I've opened up a new project file within R, and I've just kind of copied in those steps that I just showed you, just to give the framework for my new document. So I created a markdown document and just copied these steps in. I think it's usually quite good practice to do this when working with a new challenge. If you've got the steps already there, paste them into the document and you can start using that as the framework. So my step 0, if you like, really the first thing I'm going to do is import my data. I've already obtained my data, so I'm going to put in a new R chunk, and I know that my data, I can see it in my file pane. It's there in a CSV file. It's going to be quite a simple command to write, so I'm not going to use the import data set. I'm going to read it in, call it Oxford, using read.csv. And then the file name is Oxford data tidied.csv. Because I went to a bit of effort of tidying the column names, dealing with the formatting, I'm pretty confident when I read this in now, it's going to look like how I expect. So I can click on it here. You can see I've got my 7 columns. The ones I'm particularly interested in are going to be these first 4. So Y for year, and then for month. And then the T-mix, the maximum temperature, the T-min, the minimum temperature. These are the columns I'm going to be really focusing on. Kind of a useful thing to do when I've read in my data, though, even though it's in a good format, is I generally do like to run this summary command just to be confident of how each of those columns has been read in with the formatting. We can see all of them are being treated as numeric values because we're getting the summary statistics for all of them. One thing jumping out here to be careful of is in my data, I can see I have one missing value for T-min, which is going to be a little bit annoying based on how I downloaded that. So we're going to have to do something a little bit later to think about that. But otherwise, this looks good. I'm good to go. So I can move on to my step 1. So my step 1 here was calculate some yearly average temperatures. So I'm just going to think about what that means, because to begin with, I don't have a column which is average temperature. I have Tmax and Tmin. So I need to obtain averages from Tmax and Tmin. And I also have monthly data rather than annual data. So I'm going to need to summarize by year for these two steps to get to something which gives me yearly average temperatures rather than monthly Tmax and Tmin. So if I put in my chunk, before I get going any further though, I'm going to need to load in the libraries that I'm going to use for this session. So I am going to go back to the top as part of my setup chunk, and I am going to say I would like to use dplyr, and I would also like to use ggplot2. I could have just done load library tidyverse, but in this case I'm just explicitly saying the two packages that I want. So now I've got those in, I can go through these two steps. And so to get my averages from Tmax and Tmin, usually when we think about averages in dplyr, we're going, okay, we're going to summarize and use mean. But here it's a little bit different because we're actually taking the average of columns rather than the average of rows. There are a few functions which can do this, but by far the easiest way here is actually to kind of go back to first principles and to just say, okay, the average of Tmax and Tmin is Tmax plus Tmin divided by 2. So I'm just going to use a mutate function and then use that back to first principles way of calculating a mean to get to the average. So I'm going to give the name of my data, I'm going to pipe that in to a mutate and say tav equals Tmax plus Tmin divided by 2. Always be very careful with brackets, because if I run this right now, it's not going to give me something sensible. If I run it now, you'll see my average temperatures will appear to be higher than my maximum temperatures. Always remember brackets where you need to have brackets. And now my tav here, this is looking a bit more sensible. So I've summarized the Tmax and the Tmin into a tav. So let's take that next step to get it by year. So this will be a group by year, and then I'm going to summarize the tav. I'm going to take the mean of that tav. So it'll be a group underscore by on YYYY for year. And then a summarize. I'm still going to call this tav as my new column name. It's going to be a different format completely. I'm not going to overwrite this, so I don't think it's too confusing. You might want to give this a different name if you want to have a different name. Doesn't really bother me too much. If you see I run this now, my dimensions change completely. Instead of having 2004 observations and 7 variables, I've now just got 2 variables and 167 rows. So I've got 167 years of data. And you can see from my output, here's that year which had the NA value in it. I saw earlier when I did the summary of the whole data, there was 1 NA value in there. And because I didn't tell at any point R to do anything with the NA value, for the whole of 1860, it's got the value of NA as the average. There's lots of things I could do at this point to try and deal with that missing value. I'm going to be incredibly lazy and say 1861 is quite a long time ago. I'm happy enough to only look at data from 1861 and onwards. So at this point, I'm going to add in a filter and say, those first few years of data, it's not worth the hassle of trying to work out how to deal with the missing value that is in there. I know it's only 1 missing value. I saw that earlier. So I'm just going to say filter YYYY is greater than 1860. So this will now take out those first years of the data from 1853 up to 1860. So the first year of the data should be 1861. If I run this now, this was kind of a bonus step to my framework. I didn't know I was going to have to do this beforehand. So we can see now we've only got 159 years of data, and the first one is 1861. So let's think about my step 2. Now we need to calculate the reference temperature, which is going to be the average between 1971 and 2000. So there's a few different ways I can go about this. What I'm definitely going to do is I'm actually going to move my comment up here, because I'm going to try and do this all in one big long pipe if I can. So the steps I'm going to need to think about here are, I need to in some way identify the reference years, and then I need the average of just the reference years. So how I'm going to do this is I'm going to mutate and create a new variable, which, if it's within the reference year, I'm going to use if-else to say this will take the value of TAV. If it's outside the reference year, then I'm going to say it's going to be an NA value. And so then I can do a summarize, probably not a summarize, actually, I'm probably going to use a mutate to add in the average of this new column into my data. And if I tell it to ignore the missing values, this should give us the mean value only of the years in our reference period. So how is this going to work? I'm going to put in my mutate, and this is going to be my new column, which I'm going to call ref temp. And here I'm going to set this to be if else, and so my reference period is going to be y is greater than or equal to 1971, and y is less than or equal to 2000. Be careful with your ands and your ors and your equal signs here. We want it to be both greater than 1971 and less than 2000, and it's going to be equal to 1971, equal to 2000 for this purpose. So if this statement is true, my new value ref temp is going to be TAV. If it's false, it's going to be a missing value, NA. So if I run all of this now, you can see here my ref temp is all the way NAs on the first page. If I get towards the end, you can see on the last page it's also all NAs, but somewhere around here, yeah, I got to exactly the right starting point. We can see, when it's 1971, I can see 10.2, and so on, all the way through, and so on. And then from 2001, it goes back to NA. So if I calculate the mean of this column now, and I also use the na.rm equals true argument, this will give me the reference value that I'm looking for. And I'm going to put this into a new column. I could just calculate it as a single value, but because I know for every value of TF, I'm going to need to calculate the anomaly in a minute, I think it makes sense to just have a column in our data where we can just do a simple bit of arithmetic. So I am going to use a mutate again to add this for every single row within my data. So this is just going to be ref av, and this is going to be equal to the mean of ref temp, making sure I put in na.rm equals true. And there we go. We can see our average temperature in our reference period was 10.39. And if we scroll all the way through, we can see it's always 10.39. This is good. This is what I wanted. Let me move now on to step number 3. This is hopefully now quite an easy one, because all I need to do is take this temperature and subtract this temperature. So this is going to be another mutate, because I'm going to add this in as another column to my data. And this is going to be called anomaly equals TAV minus ref av. So if I run all of this now, this has now got the value, which is the key value I need to make my warming stripes plot. As you can see, just looking at these first few years of data, this is kind of negative the whole way through. I suspect if I go to the last page, I'm going to see lots of positive numbers. Yeah, pretty much every year here is positive. I think we're going to see something kind of similar to our classic appearance of our warming stripes plot here. So that's it. I've done my data manipulation steps. I have the data in the format I need, where I've got one row for each year, and I've got my temperature anomaly. So what I'm going to do, I'm going to store this data frame into an object. Because you see, at the moment, it's just being shown in the output. I've only got in the environment my original data set. So I'm going to call this at the top and call this Oxford _ yearly and use my assign operator here. So now when I run this, I won't see anything underneath, but I will see something created in my environment. There we go. I've now got 159 observations and 5 variables. So let's move on to the next phase, on to phase number 2, which is making the plot. So everything we've done so far has been using dplyr. Now making the plot, we're going to need to use ggplot2. The first thing I'm going to do, of course, is say ggplot. I've already loaded in the library, so I can now use my newly created dataset as the data input. And this is where it starts to get a little bit tricky, because I'm now going to have to think, okay, what aesthetics am I going to set, and what geometry am I going to use to replicate this warming stripes plot? So if we think of what the stripes are, each one of them is a bar of the same height, and it's being filled in based on the color of the anomaly, and we're seeing the sequence moving from left to right over time. So the two kind of obvious ones we should be thinking of straight away is the x-axis should definitely be year, and we're definitely going to fill based on the anomaly variable. So those ones should be kind of obvious, but then the question is, okay, what should our y aesthetic be if we're having a y aesthetic, and what should the geometry be? Because there's a couple of ways we can go about it. For me, I think the easiest way to think about it is to say all of these bars are of height 1, and then we can use a column geometry, geomcol, to say, okay, we're going to have one bar for each year, they're all going to be of height 1, and we're going to fill based on the anomaly. So I need to map here in the aesthetic y equals 1. I can set an aesthetic to be a constant value, and this will have all my bars at the same height. Well, technically they're columns, because I'm going to use geom underscore col. So let me run this now. And as a first pass, we're not too bad. You can kind of see, okay, I've got lots of bars, different colors. The first thing I'm thinking, though, when I'm comparing this to the classic warming stripes plot is, I've got an axis which is going from dark blue to light blue. This is not right at all. What I want is something which is going from dark blue, it's a good starting point, but I want to go up to dark red. So this is going to need me to do something to the scale of fill. And there are a whole bunch of different arguments for modifying scales in different ways. One I'm going to use now is kind of a new one, but it's quite a useful one, I think, which is scale fill fermenter, which is a little bit like scale fill brewer, but scale fill brewer works when we have a categorical variable we're using for fill, whereas scale fill fermenter, that works when we have a continuous variable like we have here. So I will say scale fill fermenter. And so here I now have to say, what color palette am I going to use? So I can go to the lookup page for the different color palettes available for the R color brewer package, which goes into ggplot2. And there is a very nice palette in there, which is just the red blue palette, which is R, D, B, U, capital R, capital B, lowercase d, lowercase u. I'm entirely sure it's BU rather than BL, but this is BU for blue. And this is almost exactly the palette which gets used in the real warming stripes plots. If you read the documentation, he modifies it very slightly, but it's basically this palette. He takes out some of the lighter colors just to make it a little bit bolder. And we can kind of see maybe why when we look at it by default, because there's a lot of white going on here. And there's a slight problem is we don't really have a centered scale. You can kind of see the negative values go down to -2, the positive values don't go as far. So we perhaps want to have a more symmetrical scale, which might be a more honest way of representing the data. And there's maybe a bit too much white going on. So we can kind of play around with this a little bit by using in here the limits argument, by giving an upper and a lower limit to help map the scale that we're using, help map the color assignment. So if I say, okay, I want this to go from -1.5 is my lowest shade of blue, up to 1.5 is my highest shade of red, something like that. You can now see I have a symmetrical scale, and also by doing that, I've managed to get myself a little bit less white. We can play around with the options a little bit, maybe. Maybe see how it is with 1.75. It's a little bit of trial and error just to get something that looks quite nice. I quite like this now by setting it at 1.75 rather than 1.5. It seems to have almost completely eradicated the white, which is nice because there's some more blues, there's some more reds. This is a bit more visually appealing. And we're pretty well on our way to getting a very nice plot here. We can see we've got lots of blues at the start, especially in recent years. We've got these nice darker shades of red, we're seeing the trends here in this Oxford data set that we see in our global plots or our national plots that we would tend to see a lot produced on their website. There's so many different countries that you can extract the data from, and it's kind of fun to do your own thing and create this from scratch yourself as well. Hopefully you think so, otherwise you wouldn't still be watching however far into the video we are, 16 minutes or so. A couple more things that I want to do though, like one of the big appeals of the classic plot is you just get a plot. You don't get all of this extra stuff around it, and it just is immediately in your face, and you have to sort of deal with this pictorial representation. So I want to get rid of all of the formatting, effectively. And there's quite a nice built-in theme, which just does this for you. So there's theme_void, and this just strips away almost everything from the background and the labels and so on. So now if I run that, the only thing I get is the plots and the axis, and the legend, sorry. I can very easily get rid of the legend as well by within the geom col, within my geometry, saying show.legend equals false. And this will get rid of the legend as well. And now there's just kind of one more thing which is sort of annoying me, which is you can see, if you look closely, there's kind of a white space here between a lot of my bars. And that's because geom col by default doesn't set the width of the bars to go right up against each other. It leaves a little bit of space. You don't quite get every single bit of space shown when I'm looking at my screen right now. It's not a huge screen. It's not like maybe fully 4K. I need to upgrade, get some more pixels. But there's kind of a bit of an annoyance that I've got this white space. So there's an argument within geom col which is to set the width. So I'm going to set width equal to 1. So each bar is going to be 1 unit wide so that they will all bleed into each other and we won't get these little white spaces in between. And there we go. You can see all of that horrible white disappears, and I just have my beautiful warming strokes plot for Oxford from 1861 up to the present day. And this was just using some pretty standard dplyr functions to bring in the data, modify it from how I need it to be, and then some fairly standard ggplot functions. Perhaps you haven't seen scale, fill, fermenter, or theme void before, but these are following similar patterns to functions that you've probably seen before and probably used before. And they're very easy to recreate this plot. If you want, you can go on the Met Office, find some more data and do the same thing for where you live, if you live in the UK. Or if you have other data available, which you think you're going to be able to manipulate. Now, just these 4 lines of code, once you've got the data into this format, you can produce your warming strokes plot whenever and wherever you want, as long as you've got R running.